and welcome to Poleshift News. Before we begin, big thank you, personal thank you to Grant Lee. I won't mention your surname, but you know who you are, and the Open Hammer Ranch project, who you'll find on YouTube. And I've paid a little visit to their channel and listened in for a couple of hours on the subjects that they talk about, and very interesting. I think it's in the same street as what we'll discuss here and what else we look at, so if you want to pop over there, by all means. I think you'll find it entertaining and very interesting, to say the least. What we're doing is having a look at the pin marks of the magnetic North Pole migration over the last 100 years. And somebody in the comment section over the weekend asked if I could show this again and just possibly, if make a prediction as to where the magnetic pole will be this time next year, and talk about some of the failing crops as a result of climate shift and that connection to the pole shift. So that's what we'll do here. So you can see at the 2018 pin, over the last 3 or 4 years, it's been moving relatively the same distance, which is about 47 miles every year. If we just measure the line from pin 2017 to 2018, you'll see it's around about that figure. If I can get it accurate, well, let's say 50 miles, there's 3 miles in it. But there you can see. So if we just forecast from there another 47 miles at its current speed and rate in which it's migrating, we should get an idea as to where it will be around this time next year. That's if it doesn't, as it has done in the past, go any faster than what it has done. So you can see at the end of this mark is where it will be. The longitude and latitude for the magnetic North Pole currently is around 84 degrees point 44 34 14 north and 137 degrees by 13 by 01 6 7 east. So if you want to go onto Google Earth, if you've got Google Earth, and pin that for yourselves, you'll know that that's round about where we are. But one thing to note, if I zoom out of this, you'll see, or if I rotate this, let's zoom out, it might be better, you'll see that it's been tracking in virtually a very straight line, and it's heading definitely for the coastline of Siberia. If it remains on track, we could be around 6 or so years away from that 40-degree mark, and I've measured 40 degrees from the start of the pole migration, which was roughly around 100 years ago, to the mark where it is now, and that's where I expect or anticipate something to happen. Now, if I just go over to our website, poleshiftnews.com, I want to just briefly mention something I think is important before we talk about anything else. So we're over at Poleshift News and we're on the TriMag data. This is the data that we collect at our observatory. Now, one of the things I'm going to do over the coming week is put a key just to explain what it is on this chart that you're looking at, or this graph. I know I've mentioned it several times to use in various videos, but I think if we've got something on there just as a key so that people can understand what it is they're looking at, I'll briefly tell you. We calibrated magnetic north at 10 on this scale, so these are in degrees if you like. The reason for doing that was because we couldn't fit, if it went slightly west, we couldn't fit the 360 degrees on there and still see these zigzaggy lines which represent 24 hours. So by doing it this way, we managed to fit it all on the graph. You can see the number of readings at the bottom, and you can see the heading in degrees at the top, and we calibrated all 3 magnetometers at 10 degrees. And you can see, like I say, the zigzag lines are in hour intervals. That's why it only goes up to 24, and then it goes back down to 1, and then starts again. So you can count the days over the last month of what was going on in there, if there is any movement. But this is another thing I wanted to talk about in this video, and that is that over the last few months, some of you may or may not have noticed that this line has started to become very, very straight, which is an indication that the pole may have stopped in its current position recently over the last 3 months, or gradually come to a halt where it is now. Now, if we look at the magnetosphere data, which we also collect at our observatory, we can see that that is still shifting up and down in microteslas, and there's a little change by about 1.8 microteslas in the deviation over the last month or thereabouts in collecting the data. But this is more important. I think what we could be witnessing is something entirely different to what we probably anticipated would be the case. We thought that once it got to 40 degrees we could see a rapid shift as the magnetic pole enters from the strong field lines into the weaker magnetic field lines. We could see a reversal. If you remember, I did a little experiment with the compass and a little magnet, and as I brought it to, as we bended encouraged the needle over to around about 40 degrees, it was at that point it flipped very quickly to the south pole. So we anticipated that might be the case on here, but something else could quite easily happen here, and we shouldn't outrule it because it is a possibility. So what might that be? Well, we might see as the poles start to weaken, they might vanish at the point at where they stop, and we could be witnessing where they've stopped. And if that is the case, then we're probably on the precipice of something happening very shortly in time. And could you imagine a world in the not too distant future without magnetic poles whatsoever? What might be happening is the dipole itself over the northern hemisphere could just simply be now that weak that it is no longer being moved about. And if that is the case, then what could possibly happen is the magnetosphere from this point on could weaken and the pole strength decrease as that magnetosphere decreases. If that is the case, then we're probably not too far off witnessing the disappearance of a magnetic pole. Maybe in a year, maybe a few more years, I don't know. It's anybody's guess. All we can do is observe what we do. Now, all I'm saying is there hasn't been a lot of progression over the last 3 months of any movement. If you remember, we got to about 10.65 degrees, and then all of a sudden that's all we're getting on the data now, which is really unusual. We've always had a little fluctuation where the pole has moved a little bit to the west and then moved a little bit to the east. Now we know that as it migrates, it circulates around a specific area of where its heading is actually. So it's going round in little circles, and it might yonder south or north a little bit more. But in general, the trend has been that it has migrated towards Siberia easterly, and it has done so for the last 100 years until recently, and this shows that our equipment's working very well. So it would be interesting now just to keep an eye on the heading of the magnetic North Pole as well as the magnetosphere to see what actually happens in the coming months and years. So how does this then affect climate in our theory? Well, from these two maps, one on the left is from SWARM's mission, and you can see the magnetic intensification. The red being the strongest, the yellow next, and then the blue, as you can see, is the South Atlantic anomaly, is the weakest. But if you compare that with a temperature chart on the right-hand side of the Earth, you can see that where these stronger intense regions are of magnetic intensity, there is on the temperature chart like patterns forming over the northern hemisphere. Now, I don't believe, and I'm sure now I'm thinking that you guys don't think it's a coincidence that we have where the magnetic poles are Arctic climates and also rotational axis. And I've said that as the magnetic North Pole migrates over the northern hemisphere, I think it is going to take along with it that climate. Now we're also seeing some of the climate, if you look at the right hand map, you'll see that that climate is going further and further easterly, that Arctic temperature. And for the first time, we've seen in some of them South China Islands ice and snow wiping out crops and destroying cattle, millions of cattle head there. It's playing havoc in that region, and it will continue to do that as long as the pole migrates over there. The other thing which is going to affect climate is the inbound cosmic rays as a result of the grand solar minimum at the moment. So how that works is it shrinks the heliosphere, because when we have lots of sunspots, lots of solar activity, and a strong sun, it inflates like an invisible balloon over the whole of our solar system. So if it starts to weaken and the activity becomes less on the sun, then that heliosphere shrinks as well, and that allows more inbound cosmic radiation. The heliosphere is a lot like the Earth's magnetosphere. Only as the sun is much larger, the field of the sun covers the entire solar system, whereas the Earth's magnetic field doesn't cover anything more at the range of our planet's inner space. So we have two things working against our climate, and they both have the same effect, which cause cloud seeding, and as a result of that, more condensation nuclei in the upper atmosphere, and eventually more water droplets. So we're going to get a lot more precipitation. As the magnetic poles weaken, I believe, over the last 30 years, I believe it has infected the polar jet streams and the subtropical jet streams, which are now, as we've seen, are mixing and interchanging. And as a result of that, we're getting hot and cold air coming together, and it's causing, havoc in regions that are usually dry or usually have monsoon periods, but their weather patterns are shifting, or their seasons are shifting as a result of that. Over here in the UK, I believe we've had an extended winter. We seem to have gone straight from winter to summer and skipped a season altogether, and this is going to all have an effect further down the line on ourselves, because as farmers have a shortened cropping season, they're not going to probably be able to squeeze in 2 crops like they usually would do, and as a result of that, prices are going to go up in food, food production is going to go down, and you add on top of that, an expanding population. We're at about 7 billion souls now. That's a lot of people to feed, and if global food production starts to get hit as a result of this, it's going to inevitably, like I've said before, end up in our living rooms. Either we experience higher prices with food staples, or other things. Now I'll just briefly mention something very important. Over the last 30 years, we've lost 20% of our Earth's magnetosphere. This is Earth's protective shield against harmful cosmic rays. You could say it's our first line of defense. The second line of defense would be the heliosphere. The heliosphere, due to a low solar output at the moment, probably as a result of grand solar minimum taking place, has already shrunk the heliosphere. And over the last 30 years, like I say, we've lost around 20% of the Earth's magnetic field strength. And this is going to continue to happen. And one important thing we have to be aware of as this happens, that we do not lose more than we dare do of our atmosphere as a result of sputtering. This was something that happened to Mars. It's very likely why Mars no longer has a magnetic field anymore, because once it lost its magnetic field, there was nothing to protect it from sputtering, which is a stripping off of its upper atmosphere. And then once the upper atmosphere is gone, then there's nothing to protect the surface waters from doing likewise. So, my worry, and it should be something that you guys consider when we're looking at all this information, is that the Earth regularly went through a magnetic reversal every 300,000 years, up until the last time, which was 780,000 years ago. and it waited another 500,000 years before it went through this reversal. So it was overdue by 500,000 years this time. And, could what happened to Mars be now taking place to Earth? And if that is the case, then it could spell the end of the entire diversity of biological life forms on this planet. In a similar manner which it probably did do, although we don't know for sure whether Mars even had any biological life forms, because none has been found yet, or at least it hasn't been announced. What we do know is that from studying the terraform on Mars is that we know it had water on its surface. We also know that it did have a magnetic pole, and it no longer has either of those or atmosphere. So my biggest concern, and has been from the time we started to look into the research in the magnetic pole shifting, has been that first of all, it's overdue. Second of all, is it going to be making a reversal even at the end of all this? Could we just simply see the loss of the magnetic north and south pole, and then the complete loss of the magnetosphere, and then from that time on, could we also lose our upper atmosphere and water on our surface? Because if that's the case, then this is another anomaly which could end humanity on this planet, as well as all the other biodiversities. And we live in a world where we take all this for granted, but we even see it first-hand witnessed on our next neighbouring planet, Mars. So when I talk about this, from the heart, usually I say to you guys, this is a big anomaly. That's a rare anomaly, and it is now back on our doorsteps. It really is. I'm not trying to fear anybody about this. It's more of a case of bringing the awareness of possibly the effects of what we are going to see in the coming future. And if there is something that we can do about it, then we should try and push our governments, if that is even possible again, to do something about it. Because you guys see probably exactly what I see at the moment, and the policies are completely for the wrong reasons. It's all about wealth. Well, you can have as much money as you want in your bank accounts and in your living rooms and wherever, but at the end of the day, if the Earth does go through even a prolonged period without a magnetosphere, and it affects the climate in a much more severe manner, then there are always still going to be 7 billion more people on the planet that are going to go through those times along with yourselves. And it doesn't matter whether you've got money at that point. You've seen it on these economic forums where it's regardless whether you've got a wheelbarrow full of money, you're not going to buy that last loaf of bread in the shop with it. It simply is going to be too valuable, and your money isn't going to be worth anything at that point. So, something to think about, guys. That's why, I've invested as much time as I have into this. I see it as probably the most fundamental change that we're going to go through as a species, and yet, alarmingly, only less than 1% of the population actually know that this is actually taking place right now. The other thing is, over the last few weeks we've been conducting some atmospheric oxygen tests which have revealed less oxygen than what should be in the atmosphere. Now, I'm not sure, I'm not convinced that there is around 18% oxygen as opposed to 20 to 21%, and for that reason, I'm going to keep my eye open for a bit more equipment which would probably give us a more accurate response. Perhaps one of the ones I saw was another oxidation method where we actually put some copper filings in a glass tube, heat the tube up with 2 syringes at either side, and we keep passing the air from one syringe connected to the glass tube whilst it's being heated up, over the copper, and then you push it back the other way, and then when the experiment cools down, you take a reading of the absorbed oxygen in the copper oxide compound. That's another way of doing it. Or we could look for something else that oxidizes relatively quick. Manganese is one. I'm not sure how we would go about lithium. I know that if you cut lithium or sodium metal, they oxidize really, really quick. I mean, to the point where you can see them, but how we would do that in a graduated tube is another thing. So, you know, I'll think about that. And like I said, I don't think it's worth me trying at this point to build some electronics which can monitor the oxygen content, because if we don't calibrate them at a certain level, we're not going to know, other than it depleting further, at what level we started at. So I think it's a good way to do this in a chemistry form, so that we can work out, or we've got a ground base of what is actually in the atmosphere. Then we could possibly calibrate some electronics to take readings every day, and that's probably something else we could have put up on the website on another page. And other than that, guys, you know, I'm going to leave it there. Enjoy the rest of your week, and you know, I'll mention the link down there if you want to support the channel. And again, big thanks to Grantley and the Open Hammer Ranch project for the contribution they made over this weekend. Guys, enjoy your rest of your week, and I'll say what I usually do. Bye for now.